Hello, everyone. Welcome to my session, IoT Device Risk Management using NIST. My name is Keerthi Nagothu. I'm a cybersecurity professional. I specialize in cybersecurity strategy, incident response, risk management, security training, and awareness programs. So, for today's session, I would briefly be speaking on what is an IoT device, NIST guidance, IoT applications, associated vulnerabilities, IoT risk mitigation goals, and risk management overview. All the discussions are from the perspective of IoT devices used in organizations, and the majority of my session is based on NIST guidance, which is publicly available. Also, I would be discussing the topic from risk management perspective and establishing IoT cybersecurity requirements. This would not cover the IoT guidance for manufacturers, which is covered under NIST 8259 series. So the total Internet of Things market worldwide was worth around 389 billion US dollars in 2020 and is forecast to rise more than 1 trillion US dollars in 2030, more than doubling its revenue in 10 years. If you look at the drivers for the growth of IoT, high speed connectivity, low cost technology, and increased cloud adoption are some of the reasons. I would briefly discuss about IoT applications in different industries in the next slide. The trend that we're seeing most of the times, IoT devices are integrated into organizations' environment without evaluation of the device security capabilities. The unique aspect or the difference between IoT devices and IoT devices is heterogeneity. IoT devices lack the functions as traditional IT devices, which is in turn creating security challenges to organizations. In terms of general cybersecurity objectives, confidentiality, integrity, and availability are important for IT devices. And for conventional IT devices, confidentiality often receives the most attention because of the value of the data and the consequences of breach of confidentiality. For many IoT devices, availability and integrity are more important than confidentiality because of the potential impact to the physical world. The benefits that come with deployments across some different industries are basically lower operational costs and enhanced productivity. So let's look at the IoT applications. So how does IoT find applications or where are they used? So if we look at manufacturing, IoT is important in the manufacturing industry because it automates operations. The operational technology in a smart factory includes programmable logic controllers, industrial IoT devices, distributed control systems, embedded systems, and more. So, in agriculture, data on soil moisture, chemical applications, livestock health, and information allows farmers to track farm operations in real time and make better informed decisions on improving farm productivity and in performing preventive maintenance. If we look at healthcare, with the help of IoT solutions such as real time remote health monitoring devices, wearable smart pills, diabetes management systems, and more, it has become easier and more efficient to monitor patients' health conditions and make treatment decisions. And if you look at transportation, IoT based safety solutions, vehicles can communicate any incoming accidents and bad weather conditions. So if you see in general usage, smart TVs, smart speakers in office, smart devices. So what is prompting this change to use IoT devices? Definitely data analytics, automation, connectivity, and remote monitoring have become part of the business operations and they're very much needed. So NIST guidance. As mentioned in the introduction slide, our session is focused from risk management perspective and establishing IoT cybersecurity requirements. And this would not cover the IoT guidance for manufacturers. So the IoT Cybersecurity Act of 2020 requires NIST to provide guidance on the appropriate use and the management of IoT devices. NIST 8259 series provides guidance for manufacturers and their supporting third parties to sell and support IoT devices for customers. These reports define the baseline cybersecurity capabilities for IoT devices from analyzing international standards and guidance. Standard Publication 800-213 series address the need for federal agencies seeking to deploy IoT devices with their systems. So NIST Risk Management Framework is the foundation for IoT guidance as well. Standard Publication 800-213 explains the role of IoT devices as elements and provides guidance for addressing the unique risks IoT devices can present. Standard Publication 800-213 is complemented by 213A, the IoT Device Cybersecurity Requirements Catalog. It is a collection of technical and non-technical cybersecurity controls defining a broad range of IoT device capabilities and supporting non-technical actions that an organization can apply in documenting their IoT cybersecurity requirements. The last one is the consumer IoT products. This guidance was developed with the intent to develop product focused outcomes that enable consumers to make informed decisions about purchasing and maintaining IoT products. So let's look at IoT capabilities. So, what does a typical IoT device look like? So, the IoT devices generally have at least one transducer, that is, sensor or actuator, for interacting directly with the physical world, and at least one network interface, example, Ethernet, Zigbee, as well as Wi Fi, for interacting with digital world. The sensor that transmits data cannot function on its own. Some IoT devices may be dependent on other specific devices such as IoT hub or systems, example a cloud for a small functionality. IoT devices used in systems with many IoT devices or maybe IT equipment. So each IoT device provides capabilities, features, or functions it can use on its own or in conjunction with other IoT and non IoT devices to achieve one or more goals. And the below list is basically not all possible IoT device capabilities, but include transducer capabilities, which interact with the physical world and serve as the edge between digital and physical environments. Every IoT device has at least one transducer capability, that is, temperature measurement as sensing and actuating. Example, electronic door locks are two types. Interface capabilities enable device interactions. Example, device to device communications, human to device communications. Supporting capabilities provide functionality that supports the other IoT capabilities. Example, device management, cybersecurity, and privacy capabilities. So let's look at the cybersecurity and privacy risk considerations. So IoT devices generally face the same types of cybersecurity and privacy risks as conventional IT devices, though the prevalence and severity of such risks often differ. For example, data security risks are almost always a significant concern for conventional IT devices, but for some IoT devices, there may not be any data security risks because they do not have any data that needs protection. So, if we look at the first risk, some of the examples of how IoT devices interact with the physical world is different. Some of the IoT devices with actuators have the ability to make changes to physical systems and affect the physical world. Another important aspect of IoT device interactions with physical world is the operational requirement devices must meet in environments and the use cases. So many IoT devices must comply with stringent requirements for performance, reliability, resilience, safety, and other objectives. These requirements may be at odds with common cybersecurity and privacy practices for conventional IT. So, if you look at the risk consideration too, in general, for IT devices, you determine the authorized people, process, and access management to the devices. In other words, an authorized administrator manages the IT device's operating system. In contrast, many IoT devices are opaque, often called as black boxes. They provide little or no visibility into their state and composition, including the identity of any external services and systems they interact with. Some of the specific aspects of IoT devices are differing lifespan expectations, unserviceable hardware, and heterogeneous ownership. So, what do I mean by heterogeneity? So, for example, an IoT device may transfer data to manufacturer-provided cloud-based service processing and storage. Data may also be sent to a cloud service to aggregate data from multiple IoT devices in a single location. So these cloud services may have access to portion or all of devices data or even access and control of devices themselves for monitoring, maintenance, and troubleshooting purposes. Another concern with heterogeneous ownership is the effect on device provisioning, what data may be still available after transferring control of a device. So, lastly, if you look at the risk consideration three, an IoT device may not need some of the cybersecurity and privacy capabilities conventional IT devices rely on. An example is IoT device without data storage capabilities, not needing to protect data at rest. So, if we briefly look at the risk mitigation goals, NIST guidance tells that cybersecurity and privacy risks for IoT devices can be thought in terms of three high level risk mitigation goals. So, protect device security. So, this focuses on the device to carry out the attacks. Example, distributed denial of service attacks against other organizations. And this goal applies to all the IoT devices. Protect data security, so protect the confidentiality, integrity, and availability of data stored on or transmitted from the IoT device. This goal applies to each IoT device except those without any data that needs protection. Protect individuals' privacy. So this is protect individuals' privacy impacted by PII processing beyond risks managed through device and data security protection. This goal applies to all IoT devices that process PII or directly or indirectly impact individuals. So, if we look at IoT risk management areas, for example, asset management is accurate inventory of IoT devices for cyber and privacy risk management forms the baseline. Same applies for privacy monitoring and analyzing IoT device for signs of breaches involving individuals' privacy. Data security monitoring IoT device activity for signs of incidents involving data security. So let's briefly look at some of the real world IoT vulnerabilities. So this slide depicts the real life examples of IoT product attacks by using the vulnerabilities. And this is quoted from NIST white paper. As you can see, as much as the applications are varied, so are the avenues for the attacks. So a real life IoT product attack and associated vulnerability basically contribute to the security incident. So let's look at some of the device cybersecurity requirements. So, device cybersecurity requirements should be based on the security capabilities and security requirements of the system and the organization, also updating this risk assessment as necessary. So, this diagram shows this process and how it draws information from all the relevant sections to inform the device cybersecurity requirements. So, device cybersecurity requirements. So, NIST 8259 series of reports provide guidance for manufacturers and their supporting third parties. So, recognizing IoT use case span many industries, but there are also some common capabilities, and 8259A provides a core baseline. To complement the core baseline from NIST IR 8259A, the IoT non-technical supporting capability core baseline is a set of actions performed by manufacturers. So these actions will help others, example, customers, end users, use the cybersecurity capabilities of IoT device and support the ongoing cybersecurity of the IoT device and the system and the networks the device connects to. So providing such non-technical cybersecurity support through educational materials or other types of non-technical tools and actions can benefit the entire IoT device ecosystem and allow manufacturers to better support the cybersecurity of devices throughout the entire device lifecycle. So let's look at the risk options. So as seen in most cases, not all IoT devices available in the market can meet the device cybersecurity requirements, which does not mean that we can use the IoT device. So likely outcomes would be like the first determination, an organization acknowledges the lack of device cybersecurity requirements but accepts the deficiency. The second and third determination involve the use of alternative capability or security control than originally intended by the organization. The third involves the organization selecting a compensating security control for the information system. And the fourth is basically the IoT device cannot be used by the organization as intended because of the lack of the capability. So if we briefly look at the challenges, what you're seeing on the slide is risk mitigation areas for each of these areas: device security, data security, and individuals' privacy. I'll not be going through each of these areas, but what you're seeing is basically the expectation and the challenge and the implication to the organization. So, as you can see, it has been divided, as I said, between the three areas. And lastly, the last category, which is decision making, this category does not have cybersecurity framework subcategories, since cybersecurity framework does not address privacy risks from authorized PIA processing. So, to get an overall understanding, the holistic picture of organizational risk management strategy, the relationship of an IoT device to an information system provides the context to understand how an IoT device supports both system and organizational objectives. IoT device as a system element shows how incrementally affects the risk it brings in, how it needs to be considered as part of the risk management process. An updated risk assessment may require additional or new controls to be selected and implemented in the system. So the second diagram shows how device cybersecurity capabilities and non-technical supporting capabilities support system or organizational security capabilities, which in turn satisfy the organizational security requirements. Lastly, I would like to conclude saying that introducing IoT devices brings in risks which must be carefully evaluated before integrating into the organization. So this is a NIST documentation slide. So right from 2019 of publishing NIST 8228, the IoT technology has been changing and adopted across various organizations. So far, there has been progress in consumer IoT capabilities catalog, and IoT diversity and heterogeneity continues to be the challenge for achieving these cybersecurity objectives. So these are basically the references I have used for this session. And lastly, I thank you for attending the session.